Examples 4 and 5 are going to be similar to what we've done with the first few, but sort of blending some of that together and adding one additional step, which we'll see. So in example 4, we have a company that manufactures and sells X television sets per month. We're given a cost function and a price demand equation and a domain for both of those functions, in this case 0 to 6,000. So the first thing we want to do is generate the revenue function, which again comes from taking X times P. So in this case, X times 300 minus X over 20. So taking X times our price demand equation. Then we want to find out when is R of X maximized. So when is our revenue function maximized? So we want to maximize the revenue function that we just generated. And actually we want to make sure we're being careful here to include that domain restriction. It may or may not change our answers, but it does have the potential to give us some different results. So in this case, R of X is maximized when X equals 3,000 with a maximum function value of 450,000. So R of X will be maximized when X equals 3,000, meaning our company will achieve a maximum monthly revenue of $450,000 by producing X equals 3,000 television sets per month. Next, we're asked to generate the profit function, which we'd again get by taking revenue minus cost. So we would get a profit function of 240x minus x squared over 20 minus 72,000. And then we want to look, where is our profit function maximized? So we would want to maximize 240x minus x squared over 20 minus 72,000 on that same domain. And Wolfram Alpha seems unhappy with what I typed in here, so let's see. Maximize, oh, I left out the 2 there, so I was getting confused with the exponent and then divided by. So update that to be x squared divided by 20. So we get our maximum profit occurring at x equals 2,400 and a maximum profit of $216,000. So our function p of x, capital P of x, is maximized when x equals 2,400. And the company will achieve its maximum monthly profit of $216,000. So a maximum monthly profit of $216,000 by manufacturing 2,400 TV sets a month and selling them for, so this is a question now that we haven't encountered yet. So in order to get our selling price, we would go back to the price demand function, which tells us that for a specific production level, what our corresponding price point should be. So what we're going to do is evaluate our price demand function. For x equals 2,400. So in this case, we get a result of 180. So we're going to get our maximum monthly profit of $216,000 if we manufacture 2,400 television sets and sell them for $180 a month. So the 216,000 comes from the profit function. The $180 comes from our price demand function. In each case, those functions being evaluated at x equals 2,400. In example 5, we're building on that problem, but what we have is some additional information. So everything from example 4 still holds, but now the government is deciding to tax our company $4 for each set it produces. So we want to first look at how does that affect our cost function. So we start with the cost function, exactly as it was given to us, but now we're adding in an additional cost. For every set produced, our company's going to have to pay an additional $4. So our cost function becomes 72,000 plus 64x. Our new profit function becomes 236x minus x squared over 20 minus 72,000. And now with this updated profit function, we want to figure out where is that being maximized. So we want to maximize 236x minus x squared over 20 minus 72,000. And now we have an updated production level, 2,360 units, and an updated profit. So our profit function will be maximized at x equals 2,360, which means to achieve that maximum profit of 206,480. To achieve that, we'll need to produce or manufacture 2,360 units per month, television sets per month, and then we would want to sell those. So again, we'd come back to our price demand function and evaluate that at our updated optimal production level and sell those for $182. So we can start seeing how as we throw additional costs into our problem, we can start causing some changes in that optimal production level, our optimal price point, and our expected maximum profits.